Hi folks, welcome back. So on my channel, on my blog, I've talked a lot about how I think skills are now one of the most important abstractions for making great agents that work reliably. However, there's still a lot of confusion around how to best use skills, and that's why I want to look at this paper. So in this paper, the authors are proposing a benchmark to measure how well skills work for various tasks. But the most important takeaway from this paper is actually when and how to use skills rather than the benchmark itself. So I'm glad they have a benchmark that quantifies all our intuitions about how to use skills, how to write good skills. But they have some very compelling case studies and demonstrations for when skills work and when they don't work. So, quick background, skills are simply structured ways of expressing, as they say over here, procedural knowledge that LLMs can put into their context at runtime to accomplish a certain task. That is mostly a fancy way of saying that skills are a collection of markdown files and maybe some code snippets or scripts that the steps in those markdown files can invoke. And I'll link to some other videos and articles on the channel previously that go into more depth explaining what skills are. Just quick side note, a previous version of this paper, I think the version that was first on Hacker News, had a different provocative clickbaity title. I think if I remember correctly, the title was Self-Generated Skills Are Useless or something like that. And yes, that's one of the things that comes up in the benchmarks, but also it's a bit of an oxymoron, and I'll explain why. So let me not bury the lead. What they did was construct a benchmark set of tasks across many different domains, software engineering, financial analysis, data analysis, so on, 11 different domains, and then measured success rate on those tasks, both without skills as well as with skills. But in the condition where it was with skills, they used both skills that were authored by humans as well as skills that were generated by the LLM itself. That's what they call a self-generated skill. And as you can see in this graph, the headline result is that yes, if you look across all the frontier models, whether it's Sonnet or Opus or Gemini or GPT, adding skills does increase the task success rate by a lot. But if you look at this hatched column, these hatched columns over here, self-generated skills don't help at all. In fact, in some cases, they hurt task success rates. So just to go over the key findings before we get into some nice concrete examples. The first finding, like you saw from that graph, was that skills do provide a substantial benefit, but it varies by task. The second benefit was that Gemini 3 Flash got the best performance, which to me was a bit surprising. My prior would have been that Claude Opus won this. So this is an interesting result. And finally, the third result is that self-generated skills provide negligible or negative benefit. All right, so we should ask, why is this the case? So if you look at what skills really are doing, they are like standard operating procedures. Under what circumstances do skills help? Skills help when you want to accomplish a task that is not very well represented in the world knowledge of the model. And so if you're asking the model itself to generate a skill, you're not really getting any advantage. So skills help when you give the model some knowledge that the model did not already have. And so intuitively, this result makes a lot of sense. And I'm glad they got empirical quantitative data to back it up. As they say in this discussion section over here, skills are meant to close gaps in the model, close procedural gaps, are most helpful when success depends on concrete procedures and detailed steps, and it's most useful on domains with specialized workflows. So domains not already represented in the world knowledge of the model. The other interesting finding was that the harness affects success rate a lot. And this also is somewhat anecdotally observed, maybe not in skills, but say in coding models where the same model, say Opus 4.5, Opus 4.6, shows different effectiveness in its native harness of Claude Code versus some other harness like Cursor. So even though the model is doing most of the heavy lifting, we're still in this phase where the harness in which the model is situated still matters and still adds to the success rate. Another interesting finding was that you want to author skills that are somewhat concise, have some working examples, as opposed to being extremely verbose. This actually lines up also with Anthropic's guide for writing good skills and good prompts in general, which is to not inundate the model with detail, but sketch out or outline the broad procedure it should follow. I want to close with my favorite part of the paper, which is in the appendix, where they look at specific cases where skills helped the most, their success case studies. So here's an example. Make a pivot table analysis in a spreadsheet. As I say over here, without skills, all 7 models scored 0%. And the reason is that they were not using this library's pivot table API correctly. They were using a Python library to create and manipulate spreadsheets. And then with a skill that said how to use this library for pivot tables, with skills providing step-by-step guidance on this library, they got an 80% pass rate. So the improvement was 80 plus percentage points. Another example, data analysis on flood data. Without skills, the agents did not know what statistical approach to use on this data set, and they had an abysmally low pass rate, only 2.9%. The skills specified the exact type of statistical analysis used and what the US Geological Survey uses. And given that data, the pass rate then went all the way up to 80%. And here's a third example where you're encoding domain knowledge in terms of regulations. So here the task was to look up SEC, the Security and Exchange Commission, filings for various company lookups and filings and analysis. So without skills, no model could complete the task. So it had a 0% pass rate. And what the skill did was point them to the right SEC API endpoints. So EDGAR is an API endpoint provided by the SEC where you can look up the various regulatory filings filed by public companies that they're required to file. And so the skills spelt out all this detail of how to look up filings, what methodology to use for then understanding the data in those filings and so on. And with skills, the pass rate went all the way to 75%. So across these 3 examples, you'll notice the pattern, and it's what we were talking about earlier, which is that these are all cases where the model doesn't have enough world knowledge, or even if it does have some world knowledge, you don't want to leave it up to chance. You don't want to leave it up to the dynamic planning of the model. When you want things done a certain way, you spell it out in a skill, and that gives you much more reliable and dependable execution. All right, so that was a quick look at this paper that proposes a benchmark for measuring the effectiveness of skills, and empirically and quantitatively verifies some of the intuitions that the community had already built up around skills, namely in terms of encoding very esoteric domain-specific processes or procedures or just domain knowledge that may not be in the model's world knowledge already, and where you have a very specific sequence of steps you want followed, you should be spelling it out in a skill. So great paper. Check it out. I'll leave a link in the description. If you like content like this, consider subscribing, like the video, and I will see you in the next one. Thanks.